Okay, 12 through 15, we're determining if the sequence is arithmetic or not. And if it is, we'll look for the common difference. Well, the way to tell if it is arithmetic is if there is a common difference. And a common difference means that from one number to the next number, we are adding the same amount every single time, or we're subtracting the same amount every time. And the notation for difference, usually we use a D. All right, -3 to -5, going up +2, and then -1 to +3, going up 4. So the simple fact that these two are different tells me it's not arithmetic, so it's not arithmetic. Check out 13. 13, we are subtracting 6, subtracting 6, subtracting 6, so it is arithmetic. And you can write that a little nicer. D is equal to -6. 14. Now the only thing that kind of looks a little different is this 1/2. So let's convert it into 6 by multiplying this by 3/3. So this is 3/6, and I can overwrite that. So here we're going up 2/6, up 2/6, up 2/6. So my difference is 2/6 or 1/3, and it must be, yes, it's arithmetic. All right, let's check out 15. 15, well, it looks like we're going up, but are we going up by the same amount every time? -1.2 to -0.1, that is plus a 1.1. From -0.1 to positive 0.8, that is plus 0.9. This is plus 0.9. We have a different guy there, so it is not arithmetic. Let's check out 16. 16, it's a scatter plot problem. Let's make a scatter plot using the data. And in this scenario, it says, shows the number of women in millions in the U.S. workforce at various times during the past century. So, let's go ahead and plot these. In 1900, there were approximately 5 million. And it looks like these these increments are by 10. So, I'm going to have to be right in the middle of the first one. And then 1920, it is about 8 million. 1940, about 10. 1950, about 16. Hold on a second. 1920, 1930. So this one is not 1940, it should be 1930. It should be right there. And 1950, try to throw you off here, is 16. So put that right there. 1970, so that's going to be here. It's 31. And 1990, 57. About here. Alright, so that was A. Maybe I'll circle it. Now let's make a line of best fit. And this one's fairly not too horrible. I'm just going to make one that looks like it could go through. It might be a little lower. We have a little bit of an outlier towards the 1990. Okay. Identify the type of correlation. In this case, I will say it's positive. And the reason why is because as the year increases, the women's workforce also increases. Okay, that's 16. 17, 18, 19, or 20, we're going to determine if the lines are parallel, perpendicular, or neither. Remember, parallel means they have the same slope. perpendicular, they have opposite reciprocal slopes, and neither of those two cases. So let's start with 17, and what I want to do is figure out what the slope is of each line. The way I will approach this is to convert it into slope-intercept form. So the very first thing would be to subtract 2x from both sides. And then divide negative 3, I should say. To cancel that out, y is equal to 2/3 x minus 3. So this slope here is 2/3. Let's see if it's the same on the bottom equation. Here I'm going to subtract 4x from both sides and then divide everything by -5. I get a positive 4/5 x minus 3. Neither slope are the same, nor are they opposite reciprocals, so this is a neither. Let's check out 18. If you get an x equals 5, this implies your slope is, so like, let me show you, like that means that 1, 2, 3, 4, 5, your line is straight up and down. So the only way I could have a perpendicular line is if my slope is equal to 0. So let's check that out. This one here, I get 2x is equal to 18, x is equal to 9, and then that actually means that 6, 7, 8, 9, I have two lines that go straight up and down, and I think I was referencing the perpendicular case, but these are actually parallel because they both go straight up and down. Both of them have undefined slopes. Number 19. I'm going to do the same again. Let me just rearrange it. And divide everything by 3. Get y is equal to negative 1/3 x plus 2/3. Slope is negative 1/3. Let's figure out this one here. 2y is equal to 6x minus 10. Divide everything by 2. Y is equal to 3x minus 5. Now my slope of 3 and negative 1/3 is actually opposite reciprocals, so this is perpendicular. And number 20. Let's see, I'm going to get y all by itself. I have y is equal to negative 1/2, because I have 1/2 minus 1, that gives me negative 1/2 x plus 1. That slope is negative 1/2. Here I get negative y is equal to negative 2x plus 3. Y is equal to, after I divide everything by negative 1, 2x minus 3. I have opposite reciprocal